All right, we are going to review factoring. This is a Math 1 concept that you should have learned last year. And so hopefully it will look familiar to you, and it should be a lot easier this year too, because I always say if you see something the second or third time, then it's a little bit easier to understand and things start to make more sense. All right, first we're going to look at factoring a GCF out of a problem. And all of these that we're going to factor today are going to be quadratics. So in other words, they're going to have an x squared in it or some kind of variable squared. It may be an m squared or n squared. So we are only focusing on factoring quadratics because we're in our quadratic unit. So anything that we do today will just have x squareds in it. All right, so GCF stands for greatest common factor. And hopefully you know how to look at two numbers and determine the greatest common factors, the largest number that can divide into both of the numbers, or if you have three numbers, all three numbers. And so one way you can do that if you struggle is you can write out the prime factorization and then see what they have in common, and that would be their greatest common factor. But hopefully you're at the point now in your math career that you can definitely determine the greatest common factor by looking at two numbers and asking yourself, what is the largest number that would divide into both of those or all three or however many factors or numbers you have. All right, so I'm just going to show you some examples here where we have to factor out a greatest common factor, and these are, again, going to be quadratics. So, for example, if I have 3x squared plus 9x. Okay, this is a binomial. There are two terms. I have a 3x squared and a 9x. And most common are GCFs. We look at binomials, and of course, we always look at them with our trinomials. So really, that's the first question you want to ask yourself. Does this problem have a greatest common factor whenever you're factoring? All right, so in this case, you want to ask yourself, what is the biggest number I can divide by with the 3 and the 9? And of course, you should have said 3. And then you've got variables to worry about. So you want to make sure both terms have an x before you can divide by an x. And you want to take the smallest exponented variable. So in this case, I have a 2, and then I have an invisible 1. So the smallest one is a 1. So I can take the x and divide by 3x. So this down here at the bottom that I'm dividing by is my greatest common factor. And the reason why we divide by our greatest common factor is because we're basically undoing a distributive property problem. So we are going to be putting that GCF on the outside of the parentheses, and that's what I'm dividing by. And whatever I get after I divide goes on the inside of the parentheses. So 3x squared divided by 3x. 3 divided by 3 is 1. X squared divided by x, you subtract the exponent, so that leaves me with an x to the first power. Plus, now I'm moving on to the next part, which is the 9x divided by 3x. 9 divided by 3 is 3. X divided by x is 1, because if you divide anything that's the same on the top of the bottom, you always get 1. So I don't need to put the 1 here, because if I did, it would look like that, and we don't do that. We know 3 times 1 is 3, and so my answer is 3x times 1x plus 3. And of course, you don't have to put that 1 up front. You can just put the x. It really doesn't matter. All right, so let's take a look at another example. If I had, let's see here, 4x squared minus 10. Okay, if I wanted to factor out the greatest common factor, you'd ask yourself, what is the largest number I can divide into 4 and 10? And the answer there is 2. So I can divide both terms by 2. And then I would say, do they both have an x? No, they don't. So I could not divide by x because this would be a problem. I cannot leave an x on the bottom. I mean, you could have, but that's not how we factor using greatest common factor. And so we cannot put an x. They don't have it in common. In order for you to divide by it, they must both have it. So here my GCF is simply just a 2. So my GCF, again, goes on the outside of my parentheses. I divide both terms by my GCF. So in this case, 4x squared divided by 2 is 2x squared. Minus 10 divided by 2 is 5. And that would be my answer simplified. That is that binomial factored using greatest common factor. And any of these problems that you do from here on out, you always want to see if they have a greatest common factor. And that just makes our problem smaller and easier to deal with. All right, the next kind of factoring you should have studied last year was the difference of squares. And these are going to be with binomials. And of course, difference means you have to have a subtraction. Squares means you have perfect square numbers. Perfect square numbers are like, oops, I don't know where that went. 1, 4, 9, 16, 25, 36, 49, 64, 81. Do you guys know what these numbers are? If you can take the square root of them, then they're perfect square numbers. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And so all I did in my head right now to get this list is I'm just saying 1 squared is 1, 2 squared is 4, so forth and so on. So now I'm at 100 because 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. 15 times 15 is 225. And that's a pretty good list. Okay, so if you can pick out these numbers when you're looking at a problem, you go, aha, I have difference of squares possibly. So you might want to learn these numbers. These are perfect square numbers. All right, so let's take a look at some examples. You have some important things that need to occur. You have to have one of these perfect numbers. You have to have an even exponent. And you have to have a minus sign. The reason why we have an even exponent is because you have to be able to take half of that exponent because each set of parentheses will get an exponent. And let me show you what I mean. So if I have, and of course these are all going to be quadratic, so I really am not going to have any fourth power or sixth powers. We're only going to have squares. So if I have x squared minus 100, if you notice I have an even exponent, I have a minus sign, and I have a perfect square number. So this is difference of squares. Because I have my perfect number, my minus sign, and my even exponent. So what you're going to do is you're going to put up your two houses. You're going to split up that x squared. So an x times x gives me my x squared. And you're going to take the square root of 100, which is 10. So each house gets a 10. And we know that a positive times a negative is a negative. So a positive 10 times a negative 10 is a negative 100. Okay? So that is what that would look like, and box it up because that is your answer. So just remember, it's got to have that minus sign, it's got to have that even exponent, and it's got to have one of those perfect numbers. And your answer is always a plus minus. Do I care if the minus comes first or the plus? No, it does not matter. The order of your plus and minus in your houses, but you have to have one of each. All right, let's take a look at another example. So if I have x squared minus 25. Again, even exponent, minus sign, and a perfect number. And this is a quadratic. This is definitely something we could see when we are graphing a quadratic, which remember is a parabola, and we can find the point of intersection, which we're going to talk about in the next lesson. So now we are just reviewing factoring. Again, x squared splits up to x times x. 5 times 5 is 25. One's a plus and one's a minus, and that is how easy that is. Difference of squares. And then another example I'm going to show you. I have to make up a problem real quick. Oops. Okay, so if I have 2x squared minus 18. All right, so this is not difference of squares because I don't have a 2 in my list of perfect numbers, and I don't have an 18 in my list of perfect numbers, but I do have an even exponent and a minus sign. So remember earlier when I said whenever we're looking at these types of problems, you always want to see if you have a GCF in your problem. So I think I have a GCF in this problem. What do you think my GCF is? That's right, it's a 2. So I can divide both terms by 2, and that would leave me x squared minus 9 when I divide. Okay, so I took my GCF out, and when I divided 2x squared by 2, I got x squared. When I divided 18 by 2, I got 9. Now, if you notice inside the parentheses, I have an even exponent, a minus sign, and 9 can be found in my list of numbers, my perfect numbers, because we know the square root of 9 is 3. So this can be factored again. X times x is x squared. 3 times 3 is 9. One gets a plus and one gets a minus. Don't forget your GCF of 2 that you took out at the very beginning. Now that is factored completely. So you just have to make sure that you take out a GCF and then see if you can do anything else with that problem, such as difference of squares. But you have to have a minus sign, an even exponent, and a perfect number. All right, so that is factoring difference of squares. Again, these should all be review of Math 1 concepts. And if you need more examples or more problems, just let me know and we can do some more of these. All right, the next one, this is the big one. This is the important one. Most of our quadratics are going to be trinomials. Trinomials means you have 3 terms. And so anytime you have 3 terms, you're going to use this form this method that we call bottoms up. And I don't know what you were told last year. You guys probably did some kind of grouping method. We used to do tic-tac-toe years ago, but we determined that that was just too much work. And so we really love this bottoms up method. Some students or some teachers may call it slip and slide. So I'm going to show you how this is done. And again, anytime you're given a problem, always look for the greatest common factor first. And then you can figure out the bottoms up method from there. All right, so this is the instructions here. You're going to multiply AC, which is the first term, by the last term. You're going to list the factors of AC. You're going to find the 2 numbers that add or subtract to equal B, which is the middle number. And then you'll set up your 2 houses. And those 2 numbers will fill in these blanks. Whatever your 2 numbers are that you have determined, they'll fill in those blanks. And then you'll divide by A, which is the first number in your trinomial, and then you'll bring your bottom up if you have one after reducing. So let me show you a few examples. Let's start off with 2x squared plus 13x plus 15. Okay, so this is a trinomial because it has 3 terms, and it is a quadratic because of the x squared. So I know that I can use bottoms up to factor this. First, I want to ask you, does 2, 13, and 15 have anything in common? Could I maybe make this problem smaller by dividing by something? And the answer is no. There's no number that I can divide by 2, 13, and 15 other than 1, but that's not going to change the problem. So now I'm ready to do the first step, which is to multiply A times C. So that is the first number times the last number. So I'm going to multiply A times C. And when I do that, I get 15. And even more importantly, that's a that's a 30, not a 15. 2 times 15 is 30. And that's a positive 30. This right here is going to help me determine, am I going to add or subtract my 2 numbers. So here I'm going to find 2 numbers that add to give me the middle number. My middle number is 13 in this case. So I need to find 2 numbers that multiply to 30 that would at the same time add to give me the B value, which is 13. So now we are going to list the factors of AC. So 1 times 30. And I usually start with 1 and just go down my list till I can't find anything else. 2 and 15. 3 times 10. So these are the factors of 30. And I also have 5 and 6. And I believe that is all I have. 7 doesn't go, 8, 9, 10. And then, of course, we start going back up my list. So these are the only factors of 30. So now, because I have this plus sign, I need to find numbers that are going to add to give me my B value. So I'm looking for my 2 numbers that are going to equal my B value, in this case 13. So when I add, I get 31, 17, ding, 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 13, and 11. So my 2 winning numbers are 3 and 10. So now I'm ready to set up my houses. And I got my X and my X in each house, and my winning numbers are 3 and 10. I don't care if you put your 3 first or your 10 first. It does not matter. Then you have to ask yourself a very important question, because I need to figure out, are these both plus signs, 1 plus, 1 minus, 2 minuses? I got to figure out the signs. This one's fairly easy because my problem has 2 plus signs, so my answer is going to have 2 plus signs. And you just want to double check that your factors of 3 and 10 multiply to give you 30. Okay, so 3 times 10 is 30. So that works out, and 3 plus 10 is 13. So double check your factors to make sure that they multiply to give you the number that you listed the factors of, and that it gives you the middle number, okay? A lot of highlighting going on here. Let me get rid of some of that. Now comes the next part where I have to divide by a. So a is my 2, so I'm going to divide by a. And so if you notice, 3 divided by 2, I can't do anything with that. So this is where the name comes in, bottoms up. So you're going to bring that 2 up with the x. And so that gives me 2x plus 3. Got that? And then 10 divided by 2 is 5. So I've lost my bottom there. I don't have any bottom to bring up. And that's my answer. I know it's crazy, but I promise you do this enough and it will be easy and fast. So this was just the first example. Some of this is new to you. Some of you guys did this last year. So hopefully if you did this last year, you're going, aha, I remember this. And if you did not do this method last year, then you are going, what? So you can pause the video, rewind, rewatch, but I am going to do multiple examples, okay? So let me get another page set up here. We're going to do some more trinomials. Let's take a look at x plus 3 times x plus 7. So if you want to, you can write this on the back side of your page where you have a blank page. And you can work with me. You can pause the video and give it a try and see if you can do it. All right. So remember, we're going to multiply the first and the last terms together. So I have an invisible 1. So 1 times 7 is 7, and it's a positive 7. I'm going to list the factors of 7. The only factors of 7 are 1 and 7. Okay, delete that. I wrote down the answer. That is funny. I'm looking at my paper wrong. Delete. Spencer has done lost her mind. All right, so we won't do that problem now that you know what the answer is. Let me write this problem down. X squared minus 3x. I thought maybe it looked a little weird. All right, x squared minus 3x minus 20. That's a trinomial we can factor. The other thing was the answer, and I couldn't factor that because it was already the answer. All right, rewind. I have to chop that out of my video, but I don't know how to. All right, x squared minus 3x minus 28. My first term is a 1. My last term is a 28. Ooh, this time it's a negative number. This might be a better problem anyways. So I've got negative 28. Negative tells me I'm going to look for 2 numbers that subtract to give me my 3 in the center. Okay, and I worry about my signs later. Some people try to fiddle around with their signs. I don't fiddle with my signs until the end. All right, so 1 and 28, I'm listing my factors. 2 and 14, 4 and 7, and I believe that's all the factors of 28. So now I am looking for a 3, but I have to subtract. So when I subtract, I get 27, 12, and 3. Ding, ding, ding. 4 and 7 are my answers because when I subtract those, I get a 3. So I'm going to put my house up, my other house, put my 2 winning numbers in there, 4 and 7. Now I have to play the number or the sign game. Figure out how do I get a negative 3 from a 4 and a 7. So how can I subtract or add or whatever I need to do to get a negative 3? So if you remember your adding and subtracting integer rules, you always keep the sign of the bigger number. So if I want my answer to be negative, then my bigger number must have been negative. So positive 4 take away 7 is negative 3. Make sure that works, and it does. Positive 4 times negative 7 should equal negative 28, and it does. So make sure you take your 2 numbers, multiply them to get you your factor list, and then add them to get your middle term. So this is how you check to make sure that your numbers work, and it does. All right, so now I'm ready to divide by my leading coefficient, which is a 1. So when I divide by 1, my problem does not change because 4 divided by 1 is still 4. Negative 7 divided by 1 is still negative 7. So this is my answer. And usually if your coefficient is a 1 and you're a really strong math student, then you know that you can just find factors of the last term that would add up to give you the middle term. So factors of negative 28 that would add up to give you negative 3. And so these could be very fast if you're a very strong math student and you know that the leading coefficient is a 1. All right, let's take a look at another example. Let me make sure I don't write the answer down this time. All right, 3x squared plus 14x minus 24. I might need a calculator. That's a big old number. All right, so when I multiply the first and the last term together, I'm going to get a negative number. I need to find my calculator. All right, so we have 24 times 3, and this is going to be a negative 72. And so factors of 72, 1 and 72, 3 and 24, 4 doesn't go into it. Yes, it does. Oh, and I missed 2, didn't I? 4 and 18, 2 and 36, 5 doesn't go, 6 doesn't go, 7 doesn't go, 8 goes 9 times. All right, so there's my factors of 72. And now remember, this tells me I'm looking for two numbers that subtract. So when I subtract, I get 71, 21, 14, 34, and 1. What number am I looking for? That's right, I'm looking for 14. There it is. 4 and 18 are my winning numbers. So I set up my two, oops, the heck? Okay, so I set up my two houses here. I have X, X, my two winning numbers are 4 and 18. So what are my signs on 4 and 18 in order for it to be a positive 14? If you said a negative 4 and a positive 18, you are correct. All right, now we have to remember to divide by that leading coefficient, which is a 3, and then bring your bottom up if you can't reduce it. So 4 over 3 does not reduce, so I'm going to bring my bottom up and get 3x minus 4. 18 divided by 3 is 6, so that becomes x plus 6, and you are done. Cool? Let's do another example. I can do these all day long if you would like me to. Let's try 4x squared minus 13x plus 3. So you can write it down, pause the video and give it a go and see if you get the same thing I'm about to get. All right, multiply the first and the last and you get positive 12. This tells me I'm looking for two numbers that are going to add to give me 13. So I got 1 and 12, 2 and 6, 3 and 4. When I add, I get 13, I get 8, and I get 7. What am I looking for? A 13. So 1 and 12 are my winning numbers. So x something 1 and x something 12. What two signs would I need in order to make that a negative 13? Negative, negative, positive, positive, or one positive and one negative. You got to think about it. Use your calculator to help you out if you don't see it. Usually my strong math students already know off the bat. Negative, negative. Again, divide by your leading coefficient. Don't forget this part, because if you forget this part, your answer is always going to be wrong here. Bottom up, because I cannot reduce 1/4, so this becomes 4x minus 1. 12 divided by 4 is 3. And that is your answer. And I will do one more. And like I said, if you need me to do more problems, I can. This one I've got 6x squared plus 21x plus 9. And I have been failing to ask you if there's a GCF on all of these. That first one, 1, 3, and 28, no GCF. 3, 14, 24, no GCF. 4, 13, and 3, no GCF. How about 6, 21, and 9? Is there a GCF? Is there something I can divide or take out of 6, 21, and 9? If you said yes, you are correct. I can divide everything by a 3. So that is my GCF. So this problem has a GCF. Oh boy. If I didn't take the GCF out at the beginning, I would have had an incorrect answer. All right, so this would give me 2x squared plus 7x plus 3. So that makes my problem a lot smaller to work with. And so I'd say 2 times 3 is positive 6. Factors of 6 are 1 and 6, 2 and 3. I'm looking for a 7. So when I add, because I know I'm going to add because of that plus sign there, I get 7 and 5. So my winning answer is 1 and 6. So x something 1, x something 6. I need a positive 7. So it will be a plus 6 and a plus 1. That gives me a positive 7. When I multiply, I get a positive 6. Don't forget to divide by your leading coefficient. So when I do this, bottom up comes up because I can't reduce that. That's 2x plus 1 reduce, and you get plus 3. Now remember that GCF at the very beginning? You have to make sure you drop that into your answer. If you forget it, then your answer would be wrong. So always look for a greatest common factor first. It's not real common to have a greatest common factor, but every once in a while they like to throw one at you just to make sure you remember to look for it each time. All right, so review these problems. Let me know if you have any questions. Remember to multiply the first and the last term together. List the factors, add or subtract, and you'll know whether to add or subtract by whether that number you multiplied by was positive or negative. Okay, so if it was negative, you would subtract. If it was positive, you'd find numbers that add to give you your middle number. And then just play the sign game to figure out if it's a positive or a negative or two negatives that go inside your winning house with your winning numbers. And then don't forget to divide by that leading coefficient. All right, so if you want me to do some more problems, just let me know, and I will sit here and work out as many problems as you want me to. But I didn't want to make this video too long and too boring for those of you guys that got it. You could probably have stopped it earlier and done your work. Let me know if you guys have any other questions. Thanks, guys.